Good afternoon, all. My name is John Ogunje. I represent Gigatech International. Today we have a very interesting topic to treat. Preventive maintenance of household solar power installations. What is preventive maintenance? Preventive maintenance is the maintenance we carry out on our system in order to avoid a break in the flow of that system. For instance, let us take this solar power installation, maybe in a 3-bedroom flat. What are the components that are here? You have number one, solar panels. You have solar panels. You have batteries. Three, you have inverters. You can name them, etc. So we carry out maintenance on all these components in order to make sure that the overall configuration, the setup, does not fail at any point in time. So that one will save you a lot of money, a lot of inconveniences, and a lot of time. So at this point, I beg to condescend to broken English so that I can carry everybody along. So what I just stop just now, be say, now the way we will typically check our solar installation so that we go enjoy what we spend our money for. The way like solar installation, I look at the things, some of the things we did. You get solar panel, you get battery, inverters, and so many others. We need to check this thing. Not be only say make we leave them for the installer. After the installer don't install them, the onus now follow you to carry out check. So that those things now we want to talk today. Now those little things now we want consider today. Cardinal Numa talk say little things are little things. Faithfulness in little things makes us great. So let us look at those little things we will not put into cognizance in our setup so that we can further correct such we would like to let's start from battery, because we don't fit just take all of them. There are so many things we do here. I feel that this is the most to prioritize, and this one will be number one, because most people battery they complain that battery don't fail. Say they buy battery. Say some people will say they don't use them for just 1 or 2 months. It's not going to work as they work again. Some say their battery catch fire. So many other. What I've heard from people. So let us look at this battery as it starts. Okay, what is the battery? What is battery? Simply put, just say a battery is an energy storage device. It is store energy. Energy storage device. Then battery. This one, the physical and cranky. But our emphasis is not on this one today. The other type we want to look at. There are so many types of battery, but the one we want kind of discuss today, what would you use for our solar installation? Now they call deep circle batteries, particularly the lead acid batteries. You understand? Batteries. Now we want to look for here now today. The difference between this and this, let me say this one. This cranky or starter battery, now they use to start, they use them to convert electrical energy to mechanical energy. Like if you want to start your motor, your ignition, as you start them, you go to roll the crank, the shaft. You understand? So it needs to deliver a high amount of energy within the shortest time. Like this one be. Example, like your car battery, trailer battery. So they not they use this one for solar. You use them, it's not good. You will either condemn or if it cause fire, if it burn your system. So this one, they're not use them for solar. Many people don't ask me, not they use this one for solar installation. They will damage them. Now this one, then they use. You understand? Why do they call them deep circle battery? Because of the DOD. DOD means the depth of discharge of this one. This one, the design I'm saying, it go dey discharging current small over a long period of time. You know, they put just a finish like that. You understand? Normally, Oyibo say make dey discharge and say 50%. Now they say not just they discharge all of them finish. 50% of this over a long period of time. So it has a very deep depth, the depth of discharge, this one. So many type of deep cycle batteries dey, but the one we want treat na the ones wey they call lead acid batteries. Okay, like we said, these are the 3 types of deep cycle batteries. You understand? The lead acid battery types, na be all these ones. But this side of the world, now these 3 major ones now we dey use for here. This one are the flooded type. Flooded type, see the one where they use water, where they top with water. The type of this one, they call them tubular batteries. Tubular batteries. This one not be sealed. If the water level don't finish, you go see top and with distilled water, and be this type. Now deep cycle. Then the second one I be gel. This one are deep cycle also. Then this one, AGM, applied glass mask. Another type of deep cycle battery. So as you see these 3, so they get different chemical composition. Chemical, that is the way they take make them. So you get it, you don't fit use the same charger for all of them. For instance, this one now, the absorb stage of this during charging is between 14.2 to 14.8 volts. This one. This gel now, the absorb charge voltage 14.2 to 14.4 volts. Why this one? This one, it take from 14.2 feed between this range to 15 volts. This one fit carry 15 volts. By the time this gel you go maintain am for 15 volts, you don't dey kill am. You understand? So the best way I can explain how we fit maintain am is say let us consider the charge cycle. The charge cycle of these 3 batteries, then we will get the picture better. So we want to look at the charge cycle. What is the charge cycle? This one, it shows the relationship between the current and the voltage. The way the voltage drops and also rise again. The way you have the constant current and at the beginning, then it drops. So in other words, charge cycle, they tell us the process where battery will fit discharge am and you will fit charge am again. For instance, make I just draw small table like this. This one now, maybe you don't discharge your battery, you don't reach to maybe 12.0. You don't say as you go charge am, you just rise up, go reach where you go stay, go come out there again, you go just stay there. Try to listen attentively. Then at this point, now be the absorption state. Let's say this is 14 point, if na gel, let's say 14.3 volts. You understand? This one are voltage. Let's just write it there. Voltage. Then the current, as you just charge them, the current go dey very high. Go dey very high until when it reach this absorption stage, it go fall. Current go fall. As it dey floating, go come dey constant from here. So this is the current. Now you will have, I will explain. You see the current here now. The current is constant. Where constant current go dey your battery, bulk. You can call it bulk. If you not call am boost, call am bulk. Bulk charging. The current here is constant. You will see the current now. It just dey constant when they enter the battery. You go surprise when you just put your battery low. It go just rise. Before 30 minutes, it don't reach this place. Some people here look and say, hey, it don't reach here, my battery don't charge you. Not be so. As it reach here, it go still need more time. I don't want to be C rating. We go reach there just now. It go need time. So no, you just say you just plug your battery, never 30 minutes, it don't reach 40, but you say, my battery don't charge. Not be so. e need to stay for this stage. Now this stage that they call the absorb stage, where the deep charging they take place. The current not too high, they don't go down, but it will remain at this voltage for a long period of time. Now there you go fit do the charging. Then after that one, it go come down, enter what they call floating. Go come down again, come low to floating. This one will be 13.5, 13.6, depending on the way you set up. You understand? So charging has three stages. Number one stage is the bulk charging or boost charging. The other one is absorb charge state. Let's call them state. C rate, or you can call it C rating. This C rating is a measure of the hour when you go fit to discharge a battery. When you fit to discharge a battery with a constant current for a known capacity of battery, or when you go fit to charge am. So if I want to know the hours, the time wey I want to discharge this battery, na through this C rating, and the current, how long it go last, na through this C rating. Now you go know. You understand? Like, come see this one now. See the capacity of the battery, 12 volts, 7.2 amps hour. This one might be the capacity. See the C rating. C rating here. See as the right hand. 22 amps hour. See some. So this one are the capacity of the battery. This one are the potential level of the battery. They see the 6 volts, 24 volts, depends on the one. In this case, now 12 volts now until it work. So like this one now, it means this battery go fit discharge 7.2 hours for 1 hour. Now it mean if you get 7.2 hours for 1 hour, then for this 20 hours, what it will be the amperage? It will be 7.2 divided by 20 hours. Now have the current. The current will go flow for 2 hours. That one will be waiting. I think it's going to be 0.3 something. Let's say 0.34 amps. Then it will be for here. So this current will flow through this for 20 hours. So that's for that. Time not actually day. This topic supposed to take up to 4 hours. We just jump. Okay, may I show you something here. See the cycle use. What did this cycle means? This one a battery weight day system. Now here now your absorbed constant voltage now it go be. See now they write this one here 14.4 to 15 volts. So if your charger they charge this into up to 15 volts, it is safe. So if I make it not pass these volts, this is your absorbed where you have a constant voltage. Your charging process, cycle use you dey use them. In this system you dey use them. You dey discharge them. Use them. A state where maybe you don't want to use your battery, but you go just dey standby. You go dey charged. After you don't charge, you go come enter this floating stage, so that anytime you want use them, you go feel use, because battery they get internal resistance. Then they lost energy even in non user. So if you want put them for standby, maybe you go connect something to charger where you go regulate, where you go be at this open circuit voltage situation. Then initial current less than this. This one they tell you say the maximum current, charge current or discharge current wey you go fit get from this battery. If I want charge this 2 kW battery now, I go put 5 amps. I don't kill am. You understand? Or I want discharge am at any point in time. I dey discharge with heavy things. Maybe I dey get 3 point something amps. I dey kill the battery. So it must fall within this ambit, this scale, between 0 and 2. Now you go fit draw or charge this battery. And also importance of this is say you go still let me know the type of charger, where the rating of the charger, the answer of the charger, where I fit to charge the battery. So all these informations e dey every battery, which we need to put into cognizance before you go choose the type of battery you want use, the type of charger wey you want use. You go see some inverter, they go tell you, if you see the back, they go write 10 amps, 20 amps, 30 amps. Some day where you go program to match the set of battery where you get. So now all these things now we need to put together. Now we need to observe so that we actually affect our battery. Number one, temperature. Temperature where our battery supposed to, they say may not less than 20 degrees Celsius, between 20 to 50. If you pass this one, you don't kill the battery. You understand? You want put battery. Now see the last video where I do. The person will put them for outside. I go say we know if we put the battery for outside like that, because the temperature where they outside, it go low below this one. It will affect the performance of that battery. So now make me come put them for box. I come box them, seal them round. So that is the ambient temperature we go do inside, it go dey between this range. So temperature, they don't put battery for where it too cold. If you put them there, it not go work well. You dey kill the battery. And if it's too hot, that's why they put battery monitor. So I go they monitor the temperature. If it's too hot, temperature sensor. If it's too hot, then you go switch off to protect the system. So temperature is very important when you go consider. If you don't say you not get temperature sensor for your own, at times they feel your battery. Take and touch and feel am and see if it's too hot, you go switch off your this thing. Temperature is very important. Then discharge and charge current or charge rate, if you call it, if you like, discharge and charge current. You know, the discharge and the charge rate is very important. You understand? As I show you that initial current, you go check the battery. They go write an initial current. That initial current they tell you the magnitude of the current where this battery, where you go fit a charger. And when you go fit a discharge at any point in time, because if you exceed this initial current, you dey kill the battery. Some people go get say just one small battery, 100 amps hour. You go just go carry 50 amps charger put. You dey kill the battery. You want to charge am so that it go charge between 30 minutes. It is not done. It's not done that way. The battery get the time when you go fit charge full. You understand? You get the time with the charge full. So we must take cognizance of this. The way you dey discharge am, the way you dey charge am, it go match the manufacturer standard. You understand? You go match the manufacturer standard and the type of batteries wey you use. We need to put all those ones into consideration. Number 4, capacity. Wetin be the capacity? You fit get 200 amps hour, 200 amps hour, the same battery, but they get different initial current. You understand? They get different, where are we? What is it called? Different absorb voltage during charging. You understand? During charging, like J and AGM. You know, you need to set that battery. Even a charge controller, whatever charger you use, you need to set them so that it will match the specification of that J battery wey you get. If na the water onu, you need to set them to match. You understand? If you not set them to match, na there problem dey come. You go see say the battery go come dey overcharge. E go dey spill. You understand? E go dey spill. E go dey bring water. And that one na problem. You don dey damage am, na be that. You understand? And that tubular battery, you go put am for where dey airtight, where air no dey flow. That thing dey emit gas, and that gas dey smell, fit cause fire for house. Oyinbo talk say that battery, if you wan install am, you go put am for place where air dey flow, or put am for a concealed compartment. You come connect pipe come out so that the gas go dey from there to the, you understand, dey come out. Those are the small things. Time no dey we go fit do all these things. Then also capacity. I measure the capacity. And also life cycle. You know, say as you dey use your battery, you use your battery, the life cycle don dey down. You know, if you compare this old one wey you just buy, new one wey you buy, come join am to this new one. It's not for here now. I go stop. Maybe in the next lecture, I will pick one battery, show you how to calculate that particular battery, how many hours it will last, how many hours you will fit a charger. I think that one will be better. We'll pick one, walk around, solve them out, So that's the purpose wey we just bring this one out na just to clear the air wey some people go say dem dey fear to install solar for their house because of wetin other experiences wey other people they get in their various places. You understand? It not be so. It not be so. Solar they work well. It's very effective. If they do am properly and the proper follow up, you go enjoy am. Though it is not cheap, it is very, very expensive. But you go fit enjoy am. Because now just the way people will just decide to stay in that darkness. As this one be so, you fit start small one. Over time, you go build am up. You understand? So you can't just avoid me just say decide to do in darkness or make you dey buy fuel every day. So we go stop here for now. Wetin we dey talk. I just dey rush am because time no dey. This thing suppose take up to 6 hours sef whenever I go do anything. So thank you for watching. God bless you.
My name is Miss Esther, and I am the Public Relations Officer of Gigatech International. I am here to tell you about the new online training program happening in August. And we are going to be teaching you about solar installations, maintenance, auditing, control, and many more. Please go to the description box for more information or call the numbers on your screen. And don't forget, like and subscribe.